Myself Yash Jivani, my student number 32116606. My course Master in Software Engineering, and our title is Cloud Native and Cloud Computing in Software Development. The reason for the topic of cloud native and cloud computing software development is increasing adoption of cloud technology in IT industries. Cloud native development emphasizes building and running applications that fully leverage the advantage of cloud computing, such as the scalability, flexibility, and resilience. Understanding this topic is crucial for business aiming and modernizing that software infrastructure and stay competitive in today's digital landscape. The agenda could include exploring key concepts and best practices, tools, and methodology associated with cloud native developments, as well as discussing the benefits and challenges of migrating and maintaining application in the cloud environment. So let's start with the what is cloud native computing. Cloud native computing is the software approach of building, deploying, and managing a modern application in the cloud computing environment. Modern companies want to build higher scalable, flexible, and resilient application that can update quickly so meet the customer demands. So to do so, they use modern tools and technology that inherently support application development on the cloud infrastructure. This cloud native technology support fast and frequent changes to application without impeding service delivery, providing adapter with an innovative and competitive advantage. How does cloud native approach benefit to business? Organize gain and competitive advantage in various ways when they build a cloud native software application. Increase efficiency. Cloud native development bring along agile practice like develops and continuous delivery. Developer use automated tools and cloud services and modern designs culture builds scalable application rapidly and reduce cost by adopting the cloud native approach. Companies don't have invest the procurement and maintenance of costly physical infrastructure. This result in a long term saving in the operation expenditure. The cost saving building cloud native solution and might also benefit your clients.
Hello everyone, my name is Yash Bhalodiya and my student ID is 321345338 and my course is software engineering. Let's talk about main foundation of cloud native computing. Hierarchical structure of infrastructure. A cluster is a set of computing nodes that are connected to each other throughout a fast local area network. On the top of the physical nodes, OS level with visualization techniques are utilized to create a VMs such as that operating cost and downtime can be minimized. By, by maintaining a pool of VMs, providing of resource can be realized with the cluster management software. Cluster management is always tightly coupled with the resource management and task scheduling. There are three major components of this infrastructure. There is infrastructure as a service, platform as a service, and software as a service. Let's discuss on cloud types. There are mainly three cloud types: public cloud, private cloud, and hybrid cloud. Public cloud. The single cloud paradigm is a new service model that delivers a complex hardware and software services to external customers throughout the internet. In order to improve the utilization of cloud resource and reduce the response time of cloud service, efficient cloud service is the key. Private cloud. A private cloud refers to a cloud infrastructure that is exclusively used by a single organization, unlike public clouds which are shared among multiple users and organizations. A private cloud is dedicated to the specific needs and requirement of a single entity, often the organization that owns and operates it. Hybrid cloud. Hybrid cloud is a cloud computing strategy that involves using services and resources from the multiple cloud providers to meet organizations' computing needs. Rather than the relying on a single cloud provider, organizations are adopting a multiple cloud approach, distributing their workloads across the different cloud platforms. The strategy offers several benefits and the addresses potential drawbacks associated with a single cloud model.
Hi, my name is Pratham Khanna. My student ID is 32115851 and my course is MSc Software Engineering. I'll be talking about data analysis. With the data analysis at service maintenance phase, we mine the service data about user behavior for discovering the cause of fault and dysfunction at this stage, enabling the reuse of the property and the same inorganic form of the job. These will be used to scale rapidly, reallocate job depending on demands. Normally, the key streams for research are defined as three. First, data analysis. Data and reveal significant aspect of the subject, help solve problem, bring to notice of the human out of the ordinary things, running jobs and suspicion events to provide a better understanding of the situation. The provision of training, IIT and LOT will inevitably help both the business to understand the cloud service, which will predict the future state with what data will be needed. The most discussed concern is having the cloud service spotting the cloud service anomalies and find root cause automatically. Second is commonly and especially individuality of data distribution. In the training that also emphasizes and depends on data type, the participant will be trained for future. A major role of AI lies in pretending the state of the disease or in detecting anomalies. For instance, the image segmentation and referring meaning of radiology images. It is also raises doubt on the training practice of developing various models for each one distinct task model and train each single module or one module per each server. On the other side, from deploying a model, training a new model for each server is not a cheap task in this case.
Hello, myself Ashish Bhavsar. My student ID is 32128186 and my course is Masters in Software Engineering. So I will be talking about the service operations. Service operations which encompasses load balancing, service migration and resource autoscaling. It is a crucial for maintaining a high performing and efficient system infrastructure. First, load balancing. Load balancing is a technique which is used to address the problem of workload imbalance across multiple containers. In cloud native environments, the primary goal of load balancing is to prevent the overloading of a single container or cluster while keeping other containers idle. Cloud native applications with a high throughput and parcel computing architectures require effective load balancing techniques. Second, service migrations. Service migrations refers to moving the service application from the original cloud or machine to the destinations. The host transfers of all system states, including the memory, file system, and the network connectivity profile to the destination host, keeping conditions without changes. Third, resource autoscaling. With the pay as you go principle, a cloud vendor allows application to dynamically acquire or release their resources on their demand. Thus, the application provides can leverage the autoscaling method to efficiently utilize the elastic feature of resource according to its budget and profit. The section introduced autoscaling is in three categories: vertical scaling, horizontal scaling, and hybrid scaling in sections.
So now let's discuss about some of the future state predictions of cloud native computing. The cloud system and service future state prediction on the one hand can alarm forthcoming failures and risks, so as to prevent them. On the other hand, it can provide basic information for task scheduling, auto scaling, service migration, and so on to improve the utilization of cloud infrastructures. The prediction of future system state focuses on three aspects. Number one, the workload. Number two, the healthy state of cloud servers. And number three, the forthcoming server service failures. At the last, I would like to conclude that cloud native as the most influential principle for web applications has attracted more and more researchers and companies to get involved in studying and using it. This survey attempts to provide possible research opportunities through a short and effective classification. We present the research roadmap of cloud native from the perspective of services computing. Specifically, we divide the development of cloud native applications into 4 states, that is, building, orchestration, operation, and maintenance. State of the art research works and industrial applications are provided. We attempted to provide some enlightening thoughts on the research of cloud native computing and services computing. We hope that this article can stimulate fruitful discussions on potential future research directions on this topic. Thank you.